Everyone, my name is Jiaqian, and I'm a PhD student of environment engineering. Um, Today, I'm very pleased to give a short presentation about some work I did over past 3 years. So today, the topic of my presentation is can Newcastle University meet the aim of net zero carbon emissions by 2030 through changing land management? Newcastle University and the Newcastle City Council have both announced the climate emergency in 2019. There are screenshots of their climate action plans, and you can find them online. So both institutions target to achieve net zero carbon by 2030. If we look at their climate action or carbon management plans, for both the university and the city, they talk about energy saving, sustainable transport, and resource management. But none of them considers the carbon stored in the institutional land. Although Newcastle City Council has proposed to protect and enhance the conic coverage of its green space from 18% to 20%, they only considered the tree carbon and neglected the soil carbon. So today, I want to introduce the aim of my study. One of my projects is to consider the potential of constitutional estates for carbon sequestration. The first objective we want to identify is to quantify the current tourist carbon storage as a function of different land usages by Newcastle University. The second objective is to predict the institutional carbon sequestration potential by land use conversion. So how I want to know the result from these two questions. First, I like to introduce, in addition to the central campus, some of you may know we have two farms. One is a Coco Park farm. Another one is Nephant farm. Also, our university manages sports ground near the urban area. In other words, all these different land types can provide us the soil types in terms of urban soil and arable soils with different farming practices. Rural soils, including conifers and broad-leaved trees. Last one is the soil types from the suburb sports ground. So we can investigate the soil carbon storage from all these different land types. From 2018 to 2020, we collect soil samples from the estate managed by Newcastle University. Here is the overview of the number of soil sampling locations and the soil collection depths. To protect the underground infrastructure, such as water pipe or electricity cable, we didn't dig below 30 centimeters in urban areas. So except urban areas, in two farms, we collect soil from 0 to 30, 30 to 60, and 60 to 90 centimeters. But today, I want to mainly show the results from the topsoil layer. This is a figure from my soil carbon density results. Here you can see the top centimeter soil density from central campus is higher than arable and woodland soils at the two farms. And at the two farms, the woodland soils stored more carbon than arable fields. For different types of woodlands, soil carbon under coniferous woodland is higher than broad-leaved woodland. At Coco Park Farm, the long-established woodland accumulated more soil carbon than recently established woodland. Also, in Coco Park Farm, the soil carbon from permanent pastures is higher than other crop fields, and this difference shows has a statistical relationship. And however, in Neffington Farm, although the soil carbon from permanent pasture is higher than other crop fields, but it's no statistical difference from this group. Also, we know there is a division between conventional and organic in Neffington Farm, and my results found there is no statistical difference between these two groups of soil carbon data. For land with tree cover, the tree biomass carbon is quite an important contributor to the tourist carbon. Thus, I conducted small area sampling in the farm woodland, which includes 147 single trees, covering 6 tree species. And in our urban campus, thanks to the data support from estate office, I could get the tree parameters from the entire campus area. So it includes 473 single trees, covering 67 tree species. This figure shows the tree carbon density from different locations across the Newcastle University. And here, it clearly shows the tree carbon in rural woodlands is higher than urban trees. And at the rural woodlands, the tree carbon density from conifers is higher than broad-leaved cover. This slide shows the tourist carbon storage for the different study areas. The tourist carbon store of the urban campus is the smallest one, while the value from Neffington Farm is the largest one at over 66,000 tons. So if we add these three values together, we could know in total over the area managed by Newcastle University, the tourist carbon storage is over 100,000 tons. This value is 17 times higher than annual carbon emissions of Newcastle University in 2019 to 2020, which is 6,400 tons. So since we understand the basic carbon storage from different land uses, what should we do next to sequester more carbon in the estate managed by our university? At the farms, we know soil carbon from conifers and from pastures is higher. So here, we proposed some scenarios to sequester more carbon in our lands. For example, under scenario 1, we wonder, can we convert all lands at both farms to coniferous woodland? And here, the time for trees become mature, we set is for 40 years because the average tree age from both farms we calculate is 40 years nowadays. So under this scenario, we could know for this annual carbon sequestration we could achieve is over 3,000 tons. And under scenario 2, we think about how to convert one of farm, for example, Neffington Farm, to forest research with 50% broad-leaved and 50% conifer woodland. Thing we set the time for trees become mature is 40 years. Under this scenario, we could achieve the carbon sequestration is nearly 2,000 tons. Under scenario 3, we want to convert cropland use at the farms back to the split between pastures and crop fields shown on a historical map. This historical map you can find from our university website. This map shows how the manager used the farm around 1900. And this time we set the time for establishment of completely grown pastures is 5 years, based on the information we found from this historical map. So under this scenario, we could achieve the annual carbon sequestration is over 4,000 tons. You can see this data is almost 8% of our institutional annual carbon emissions in 2019 to 2020. On the central campus, the carbon sequestration contributed by land conversion is more limited due to the lower land cover area. For instance, based on our tree carbon storage estimation, the fourth tree species showing the highest tree carbon density is this four. First is ash, second one is Swedish white bean, third is sycamore, and the fourth is large-leaved lemon. So we considered if we introduce these four tree species to the total urban green space areas managed by our university, the percentage of estimated annual carbon storage to the current annual carbon emission of our university would just 1.14%. Under this scenario, the total carbon augmentation potential we could achieve by 2030. That means if we conducted this project now and in the next 19 years, we could achieve the tourist carbon storage around 659 tons. Finally, let's go back to the study aim and our results. So for the first objective, we know in the areas managed by our university, the soil carbon of permanent pasture is higher than soil carbon of crop fields, and soil carbon of coniferous woodlands is larger than soil carbon of broad-leaved woodlands. For the second objective, we understand for the significant offsetting, we should consider more from the rural estate. We could think either expanding the woodlands or introduce more pastures. So these two ways would be tangible methods for all our university to achieve net zero carbon by 2030. That's what I gonna share. That's what I want to share this morning. And thanks for your listening. Do you have any questions?
Thank you very much, Jiaqian.
You're welcome.
If anyone hasn't got a question, I'll go first. I actually have a couple of questions. Why do you think that there was more carbon in the urban soils than those in the pastures? Do you think that was related to pollution?
Pollution, we don't think that factor because I didn't show the soil collection map in this presentation, but the soil we collected over the campus is all the greens area around our buildings. For example, the grass areas next to the old library or near the near the Robinson Library. So this urban area, we still collect from the grass. We think the difference about the soil carbon density between the pastures and urban green areas, it's mainly conducted maybe by the fertilizer application or the grass maintenance. The difference of grass maintenance between our urban campus and the farmlands.
Go ahead, Matt.
Thanks, Tom. Thanks, Jiaqian. I have too many questions to ask now in this forum, but it's great to see this work, and I'd really like to follow up with you to explore what you've done in more detail and just to understand a little bit more about some of the differences in some of the stats you showed. Tom highlighted one. I had the same question, but just to understand the differences in carbon around different approaches to at the farms, because this is obviously, as I mentioned in my presentation, an area that we're starting to look at. So although we're aiming for net zero by 2030, one of the questions I have is, when do we need to start planting nature-based solutions to achieve some of that sequestration by 2030. I don't want to wait till 2030 and then, only achieve it, 40 years down the line. So we need to be thinking about it now. So I'd love to follow up with you and just learn a bit more about the research you've done. It's great. Thank you.
Yeah, thank you. That's what we want to introduce our project to the managers of our university. Also, we have an interview with farm managers and also the one team leader from the sustainability team, and from the estate office. We want to know how they consider tree planting around our campus. They have different ideas because they take charge of different departments. So they want to sequester more carbon to achieve net zero, but they also need to consider the interests from other groups. For example, the manager of our estate office, they need to consider how do we need to make especially in our central campus, how do we plan tree planting instead of disturbing so many like I mentioned, like underground infrastructure. Also, our campus located in the central of city. So how do we manage that? Could we would so we the manager wants to provide different types of trees for the staff, but based on my project, some tree species, particularly showing the highest tree carbon density. But if the estate manager want to keep the biodiversity over the campus, they still need to think about do not just plant the single trees. We only pay attention to their tree carbon density. So this is one question they proposed to me, and also the thing we want to do is if we want to plant trees, it would be more earlier, much better. But So, but this is kind of a very big project, and we need to negotiate with each party. We want to make sure to keep everyone's